In this video, we're going to look at the brain. This is an inferior view. In this view, we can see the frontal lobes, the temporal lobes of the cerebral hemispheres, and we can see all of the cerebellum, both hemispheres of the cerebellum, so the left and right cerebellar hemispheres. Again, this is upside down, so in the cranial cavity, it would be flipped. If we zoom in just a little bit, you can see the first cranial nerve set, the olfactory nerve. So these are the olfactory bulbs with the olfactory tracts running back. You can see the remnants of the second set of cranial nerves, the optic nerve. This is the pituitary gland with the infundibulum, the little stalk that suspends it from the hypothalamus. We can see two of the three components that make up our brainstem. The brainstem consists of the midbrain, the pons, and the medulla oblongata. The midbrain is a little obstructed from this view by the pituitary, but it's back here. The pons is this embossed area on the anterior of the brainstem, and then the medulla oblongata. And again, this is upside down. Now let's look at some of the lobes of the brain. In this view, we can see each of the frontal lobes, each of the temporal lobes. If we turn it laterally, we can see the parietal lobe and the occipital lobe. And again, the temporal lobe here. This is the longitudinal fissure. It separates the cerebral hemispheres, and it's big and deep, as most fissures are. The grooves you see all over the surface of the cerebrum are called sulci. That would be plural, and a single one would be called a sulcus. So this is the lateral sulcus. It separates the temporal lobe from the frontal and parietal lobes. You have a central sulcus, and the way to identify the central sulcus is it will run from the longitudinal fissure all the way down to the lateral sulcus here, unimpeded. So it doesn't get obstructed in any way. It's a steady flow all the way down. So we have this as a landmark, and it is the line of demarcation between the frontal lobe and the parietal lobe on both sides. So this would be your precentral gyrus and your postcentral gyrus. The ridges you see all over the brain are called gyri, and one would be called a gyrus. How about that? So precentral and postcentral gyrus. Now, if we want to look at the separation between the parietal and occipital lobes, you have to look at a sagittal view here. And you can see it right here. This sulcus that goes unimpeded from the surface of the cerebrum all the way down to the cerebellum separates the parietal lobe from the occipital lobe. Also in this view, we can see the corpus callosum, big commissural region connecting both the cerebral hemispheres. You can see part of the thalamus here. Now the thalamus is a much larger structure than you can see in this view. There's two thalamic hemispheres. Each hemisphere resides in its appropriate cerebral hemisphere, so they're deep to this, but they're a substantially sized structure that we will see a little later in the video. I'll use another model to represent it. So this would be all you can see of the thalamus in this view, and this would be the hypothalamus right below it. Hypo means below. Below the hypothalamus, you have the optic chiasm. Now this is where the two optic nerves come together and the fibers actually cross over. But this is a sagittal view, so they've cut right through the optic chiasm. And right about here, coming off the hypothalamus, is where that infundibulum would be suspending the pituitary. This area where you see the thalamus and the hypothalamus, it's slightly cavernous. It's shallow, but slightly cavernous. Now, when you put the other half with this and look at it in an anterior view, it creates a very narrow cavity. We call that the third ventricle. So this would be the area of the third ventricle. You have a lateral ventricle in each of the cerebral hemispheres. We'll see that a little later when I use a model of the ventricles to show you those cavernous areas. This is your cerebral aqueduct. Now, what you're seeing here is the midbrain. It looks like it's really two different pieces, but it's a solid structure with this canal running through it. This is the cerebral aqueduct. That connects the third ventricle to the fourth ventricle. And all of these ventricles I'm speaking about are filled with cerebral spinal fluid. that cerebrospinal fluid is produced by the choroid plexus in each ventricle, which is a specialized set of capillaries you see here represented in pink. This blue vascularization is simply the venous return. So you have the choroid plexus of the third, it goes up and it extends into each of the two laterals, and you'll also have another choroid plexus in the fourth ventricle down here. And then right around here, there are apertures that allow the flow of the cerebrospinal fluid to go from the ventricular system into the subarachnoid space, which surrounds the brain and the spinal cord, and it actually helps to cushion our brain from impact. If we look at the brain stem here now in this view, you can see the midbrain, the pons, and the medulla oblongata right here. Below about this level of the probe, where I have the probe, below that would be the spinal cord, because about the level of the probe would also be where your foramen magnum would be of the skull. And so here is where your spinal cord would exit, and you'd find it then housed in the vertebral foramina of your spinal cord, your vertebral column. This here is a sagittal section of the cerebellum, and you notice the white matter is internal to the gray matter. The same holds true for your cerebrum. White matter is internal to the gray matter. It's the opposite in the spinal cord. We have a butterfly of gray matter in the center of the spinal cord surrounded by myelinated white matter. This white matter in the cerebellum is referred to as the tree of life. The arbor vitae is the clinical name, arbor vitae. But arbor vitae means tree of life, and in fact, if you were to Google this, arbor vitae, you'd probably see images of the plant itself, as well as a sagittal section of the cerebellum. Finally, right here at the base of this choroid plexus in the third ventricle is your pineal gland. This is your pineal gland. It's a little gland that produces melatonin. So there is your brain, both in sagittal view, lateral view, and earlier both hemispheres showing you the longitudinal fissure. So here is the model of the thalamus. Now, it's a pretty big structure. If you look, these are your thalamic hemispheres. There again is your pituitary gland, suspended from the infundibulum. Here you see the remnants of your optic nerves. Here's your midbrain all the way around. You see the midbrain. It's a solid structure, but in that other view, it looked like two parts separated by a channel, and that's in fact the cerebral aqueduct running right through the midbrain, connecting the third ventricle to the fourth ventricle. Now, the fourth ventricle would be here. It doesn't look the same because we're missing our cerebellum. So that's your midbrain, this is your pons, and then this is your medulla oblongata right here. So midbrain, pons, medulla oblongata. And below this would be your spinal cord. So right about here would be the level of your foramen magnum of the skull. Okay? Now, if we open this up, take it apart, and we look at this view, it looks just like what we saw in the brain. Okay? So appreciate this is a very large structure internal to the cerebral hemispheres on either side. These are the ventricles of your brain represented in this model. If I take this out, you can see the two laterals, 1 and 2, and then you can see the third ventricle. Remember I said that was a shallow cavernous area in the brain representing the third ventricle, and there it is. That's what would occupy that area. In fact, this hole left here is what would have been occupied by the intermediate mass, the segment of tissue that connects the right and left thalamic hemispheres. And right about here would represent your hypothalamus. If we turn this to the posterior, you can see your cerebral aqueduct coming down to where the fourth ventricle would be. And note on this model the pink areas. These are representing those choroid plexi. So one in each of the laterals, a choroid plexus in the third ventricle, and then the pineal gland would be down here, and then a choroid plexus in the fourth ventricle. And remember, this is a representation of the cavities inside your brain that are filled with cerebrospinal fluid being produced by the choroid plexus in each ventricle. So those are the ventricles of the brain.